Welcome, everyone. We are standing at the edge of the biggest paradigm shift in the history of cybersecurity. The era of manual bug hunting is over. Today, we're exploring why the traditional Pentester is dead and how you must evolve into an AI operator to survive. Let's get started. Let's begin by defining this massive shift. What does it mean to be the last Pentester? It means the transition away from manual vulnerability discovery toward AI-orchestrated operations. The basics are stunning. Frontier AI models like Claude Mythos are autonomously finding thousands of zero-day vulnerabilities across every major operating system. Why is the traditional role dead? Because humans cannot scale. AI models have compressed the exploit development lifecycle from weeks down to mere hours. How does your job change? You will no longer write exploit code by hand. Instead, you will act as a commander, deploying and managing swarms of AI agents. In our deep dive, we realize that as these models become incredibly capable, the bottleneck is no longer finding the bug. The new bottleneck is orchestration intelligence deciding where the AI should look, how it should look, and when it should verify its findings. Look at this flowchart to visualize your career evolution. On the top path, the traditional Pentester performs manual code review to find a single vulnerability and manually writes an exploit. It's slow and linear. On the bottom path, we see the modern AI operator. Your new job is to orchestrate an agentic AI swarm. This swarm performs machine-speed scanning to identify thousands of zero days simultaneously, leading to the autonomous generation of weaponized exploits. You are no longer the foot soldier. You are the general. Why exactly is human speed security obsolete? It's about the collapse of the patching window. What this means is that vulnerabilities which survived decades of rigorous human review are now being uncovered instantly by AI. The basics are terrifying. AI models excel at understanding structured languages like code, easily spotting subtle logic bugs that human eyes and traditional fuzzers entirely miss. How powerful is this? Anthropic's Mythos autonomously discovered a 27-year-old critical vulnerability in OpenVSD and a 16-year-old flaw in FMPEG library that automated tools had tested 5 million times without success. For our deep dive, let's look at the economics. At a compute cost of under $20,000 per campaign, these models are achieving full Tier 5 control flow hijacks on fully patched targets. The cost to completely compromise a system has plummeted, and humans cannot manually patch fast enough to stop it. This timeline highlights the crisis. When we look at time to exploit, a human hacker takes weeks to months. This traditional pace gave the defender time to issue a patch. But look at the AI agent path. The time compresses to minutes or hours. The zero-day is exploited instantly, eliminating the human reaction window entirely. The only logical conclusion is the final node. Machine speed defense is now strictly required. How is an AI actually doing this? Let's look at the mechanics of agentic hacking. What is it? It's when an AI functions as an autonomous operative, capable of setting its own goals, selecting tools, and chaining vulnerabilities together. The basics are that traditional scanners just look for known bad signatures. But frontier models use deep semantic reasoning to understand what the code is actually supposed to do. Why is this necessary? Because bypassing modern operating system defenses requires highly complex, multi-step execution. How does the AI do it? Mythos has autonomously written complex JIT heap sprays to escape web browser sandboxes and split 20 gadget ROP chains across multiple network packets to gain root access on servers. The deep dive reality is that the AI autonomously discovers memory primitives, strings them together into an exploit stack, and bypasses advanced mitigations like KSLR completely on its own. It hacks exactly like an elite human. This sequence diagram maps the autonomous exploit process. The AI operator model instructs the memory analyzer to identify out-of-bounds read or write primitives. Once confirmed, the AI synthesizes a complex JIT heap spray and ROP chain internally. It then fires this chained exploit stack directly at the target OS kernel. The kernel, completely fooled, grants root privilege. As noted, the AI manages to bypass hardware-level randomizations like KSLR completely autonomously. If the AI is writing the exploits, what is your job? Welcome to the new era of orchestration intelligence. What this means is that your role is shifting from manual exploitation to strategic management. The basics are simple. You will soon direct AI activities much in the same way that a product manager directs a team of human programmers. Why is this a skilled job? Because running frontier models is expensive. You have to optimize a limited compute budget across massive, million-line enterprise codebases. How do you do this? By implementing frameworks like VCAO, which intelligently allocates analysis budgets across different files and tools. In our deep dive, we see the operator defining the strategy. You tell the AI to rank the codebase, giving maximum compute budget to files that parse raw internet data, while spending less time on internal logic files. You deploy fuzzing agents, CodeQL agents, and reasoning models in a coordinated symphony. This architectural diagram displays the verifier-centered agentic orchestration framework. At the top sits you, the human AI operator. You define the strategy and budget and feed it into the agentic orchestrator. The orchestrator then allocates resources down to specialized tools, a static analysis agent, a fuzzing agent, and a memory safety agent. They all feed vulnerability candidates into a cascaded verification layer, which filters false positives and outputs a final, validated 0-day. You manage the machine that does the work. Let's look at the technical implementation. How do you build an AI hacking environment? What you are building is called an AI scaffold. The basics involve placing the frontier model into an internet-isolated container, providing it with the target source code, a compiler, and standard debugging tools. The interaction starts with a surprisingly simple master prompt from the operator, such as "Please find a security vulnerability in this program." Then, the autonomous loop begins. The AI reads the code, forms hypotheses, injects debug logic, runs the executable, and iteratively refines its attack until it succeeds. For our deep dive, let's talk about quality control. A skilled operator builds cascaded verification loops. This means you spin up a secondary AI agent specifically tasked to act as a judge. It reviews the exploit generated by the primary AI to ensure it is actually exploitable and not a minor, unweaponizable false positive. This sequence diagram maps the scaffolding interaction. The AI operator initializes the sandbox scaffold. The operator prompts the Mythos attacker model to find a vulnerability. The model enters an autonomous execution loop, reading code, compiling, and analyzing crash logs entirely on its own. Once it generates an exploit proof of concept, it submits it to the Mythos judge model. The judge verifies the payload and delivers a confirmed Tier 5 exploit back to the human operator. As an AI operator, your threat modeling must evolve drastically to handle cross-domain attacks. What does this mean? It means frontier AI models can reason across entirely different technological domains at the same time. The basics are that human hackers typically specialize. You have cloud experts and you have hardware experts. But the AI holds expert-level context on all of them simultaneously. Why is this devastating? Because modern enterprise networks are interconnected. How does the AI exploit this? Mythos has demonstrated the ability to chain a minor web API vulnerability on the perimeter directly into an internal logic flaw, bridging the gap to secure databases seamlessly. The deep dive reality is that you must deploy cross-domain red teaming. If your defense only focuses on patching the cloud, the AI will autonomously calculate a new attack path through your embedded IoT devices or operational technology to reach the exact same objective. Here we see a classic AI-generated cross-domain attack path. The attack starts on the left at a web API with a minor flaw. The AI instantly chains this logic into an Active Directory pivot. It hits a cross-domain boundary, but instead of stopping, it bypasses it using a cryptographic downgrade to compromise an embedded OT device. This final hop leads directly to crown jewel data exfiltration. The AI sees the entire enterprise as one continuous puzzle. Let's apply this to a critical, real-time use case: autonomous red teaming. What is it? It is utilizing frontier AI defensively to patch your systems before the bad guys get their hands on the same technology. The real-world scenario is Anthropic's Project Glasswing, which provides defensive Mythos access to top enterprises. In execution, you, as the AI operator, deploy this model continuously against your own proprietary codebase. It functions as an autonomous SoC. The result is that the AI scans your network 24/7, anticipates complex exploit paths, and generates predictive patches for 0 days before they are ever weaponized in the wild. In our deep dive, the lesson is clear: to survive the coming vulnerability tsunami, you must adopt a machine versus machine posture. You must leverage AI to ruthlessly break your own code and deploy fixes faster than human adversaries can even read the source code. This flowchart maps the autonomous red teaming loop. The enterprise codebase is continuously fed into a defensive Mythos instance. Through autonomous scanning, it asks, is a 0-day found? If yes, it simulates the exploit path to verify the risk and generates a predictive machine-coded patch. You, the human operator, step in only at the end to approve the logic. Once approved, the patch is deployed to production, neutralizing the threat entirely. To conclude, the role of the traditional pentester is dead, but the role of the cybersecurity professional has never been more vital. The paradigm has shifted permanently. AI has crossed the threshold where its vulnerability discovery and exploitation capabilities vastly outpace human manual effort. The era of static, point-in-time security audits is over. Your mandate is to integrate AI directly into your development lifecycle, forcing a massive shift left in security. You must enforce absolute zero trust and continuous identity governance to halt autonomous lateral movement in its tracks. The future is clear. Computers will soon program and hack other computers. Your value as a professional will lie entirely in strategic oversight, architecture, and AI governance. To master the tools of the modern AI operator, future-proof your career, and secure your enterprise, I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you for joining me. Our final mind map summarizes the core competencies of the new AI operator. At the root, you must master orchestration intelligence, managing agent budgets through frameworks like VCAO. You must implement machine-speed defense through predictive patching and autonomous red teaming. You must think in terms of cross-domain strategy, understanding how attackers pivot from IT to OT. Ultimately, your job is strategic oversight, utilizing cascaded verification to control the immense power of these frontier models.
To find related ebook and other material for this training course, go to quicktechie.com. Now you will see all the video courses are available here. So let's move to the ebooks. You can go here, ebooks, all AI related ebooks, like you are watching currently Mythos related training. That ebook would be uploaded under this section. You can download this ebook. PDF would be available, all 300-page PDF. So you just click on the download this entire ebook. You can download from this section. So whatever training you are currently listening, corresponding ebook would be available. We have thousands of ebooks available. Now, other than that, we have on video courses which you are watching right now. This also all AI related courses are available. Similarly, for all company related trainings are available, like Microsoft. You can find it here with their respective certification training modules. All exam simulators which would help you to get the certification preparation. Just refresh if you get this kind of error. Okay, so now you can see these are all certification preparation materials. Will also be click here to the NVIDIA certification preparation material. So you can see all NVIDIA certification preparation materials, and click on any of this and it would load the entire screen and you can launch the practice paper. So this is what you can see, that you can submit the answer. We have an audiobooks available. Okay, so for each section, and these are our alumni who can you can find out all alumni who are accessing our portal